Hi team, welcome to my session on Coffee with Prab, and in today's podcast we're going to discuss about exam summary of CISSP Domain 3. My name is Prab, and for more information you can check my LinkedIn profile. So let's start with the first part. Now when you're talking about Domain 3, which is called as a security engineering, and it is considered as one of the biggest domain of CISSP, and I've seen a lot of people drop their plan after reaching a Domain 3. Now, what is included in the domain 3? You need to first understand that. So domain 3 start with called as a security design principles, where we have a lot of topics around threat modeling, least privilege, defense in depth, secure default, fail secure, keep it simple, zero trust, privacy by design, trust but verify, shared responsibility. So these are called as the security design principles we have. So security design principle is all about the rules for building a secure system. Let's say example, I want to build an application, right? So during a design of an application, I'm adopting the threat modeling. So threat modeling is also one of the security design principle. Same like we have others. So first we discuss about least privilege. So least privilege basically mean to ensure the user and system have only access they needed. So during a development, during not development, before moving to development in the design stage, we consider, okay, the user requesting for this kind of a query, it should ask for the username password. Like in a Linux, if you want to run any kind of administrative activities, you need to run a sudo command, right? So they have designed that in their mind, and then later on they introduce in a development step. Second design principle we called as a defense in depth, which is called as a layered security control, which provide the multiple line of defense. Third, we have a privacy by design, introducing a privacy in the design stage instead of adding in the later stage. So let's say example, we had a meeting, and during a meeting we had a discussion, okay, whenever any application should call for any executions and all that, it should ask the user consent. That's why, when you're installing any kind of a mobile app or anything, it asks for your consent. Like this application is going to access your email address, passwords and all that, email address or messages. So without your consent, they cannot able to access that. So they have designed during a design, they have this discussion. So during a development, they can add that functionality. So that is there. Then we also have another security design principle called as a economy of mechanism, which is called keep it simple. And Google is the best example of the keep it simple. How, let's say example, you log in once and based on that, you can access the Google Drive, Google Files and everything, right? So log in once and access everything. And they also give you the option of federation, where you can use their credentials to access the multiple domains and all that. So by this, we have unnecessary functionality has been disabled. We look for the simplicity, and we also look for the operational ease of use access. Third example, those who are from India, you can take the example of CoWIN portal. In CoWIN portal, what happened? You just enter the phone number, you get the OTP and login. So these are some examples of economy of mechanism. Another security design parameter we called as a type of system. So we have two type of systems: open system and closed systems. Open systems are on the one hand, it is designed to agree upon the industry standards like Android, and closed system is just like iOS. Another important thing you need to know is zero trust. Now, when you're preparing for the CISSP, you should know the ultimate goal of zero trust, which say no trust but verify. So when it comes to the zero trust principle, if the context talk about which is the security design architecture we used, in which we always assume breach, and based on that we give access, then answer is zero trust architecture. Because traditional network, when we're talking about the user once authenticate, he can have access to all the resources. But now when the user try to connect on the enterprise network and all that, they verify the identification, authentication, user behaviors, and based on that they give access. You can take a zero trust in this way. Initially when you used to ask your dad or your mom, Papa, can I go for the party? So they said, yeah, definitely you can go for the party. And Papa, I'm going for studying with my friends. Oh, definitely go. One day what happened, your neighbor has saw you watching a movie on theater, but you have lied to your mom and dad that you're going for tuition. So this is basically where they break the trust. So next time when you asking for, Papa, I want to go for tuitions, they will say when you come, why you going, with whom you're going. So asking multiple things. So every time when you go out, they ask you multiple questions, because now no trust, always verify. So zero trust is the same like a security framework that operate on the principle of never trust, always verify. And because of the evolution of the global workforce and all that, they introduce this concept. So core principle is least privilege access, microsegmentations, continuous monitoring, and context-aware access. And zero trust was introduced to address the limitation of traditional perimeter-based security model, which is assumed that the threats exist only outside the network. So with the rise of cloud compute, remote work, BOID, and sophisticated cyber attacks, the traditional castle and moat approach has become inadequate, and that's why they introduced this process. So now what happened? Every device or user will go through the strong multi-factor authentication. Then we check the device health. Then we check the policies, like we verify the identity, device, location, behavior. Like user trying to access a finance system from unknown location, so it can be denied. And then once they have validation, they can access a particular system which is part of microsegmentation. And once he accesses that, with the help of continuous monitoring, we track those activity and everything is encrypted. So that's a live example of the zero trust architecture. Along with that, there's so three principles. Always remember: always verify, use least privilege access, and assume breach. Now, next module in this is called as a security architecture. See, security architecture is another important topic, especially SABSA. You must know SABSA, especially the SABSA layers. So let's say example, SABSA is a security architecture, which is a risk-driven architecture, which used to integrate security in your business process. Now let's say example, you want to build a house. So you create a strategy, like you want a cement, you want phase 1, you need phase 2, you need phase 3. But question is how to organize that. Same like you're planning for a 2K marathon, okay, running. And you create a plan that, okay, I will go gym, then I will do workout, I will do running, I will have my nutritions and everything. But problem is that you don't know how to organize that. So architecture basically help you to organize all these blocks. You create a timetable. The timetable is an architecture. Same like when you're building a house, okay, you have a cement, you have a labor, you have workers, you have time and everything, but you need to organize everything. That is so where you create an architecture of your house. Visualizations. So same like when the organization go for any kind of a security initiatives as part of security strategy, they need to follow architecture. And here one of the architecture we follow is SABSA. Now in SABSA, you need to know the layers. So first is called as a contextual layer. So let's example, the purpose of contextual is to align with the business goals. Let's say example, the company want to enable the secure mobile banking to gain customer trust and competitive advantage. So based on the context, we have a conceptual where we define the security objectives, like I want to protect customer data and ensure the transaction integrity. Then we have a logical layer which define the logical security processes, like use multi-factor authentication, TLS encryptions, and monitoring tool. And then we come to the physical, where we talk about implementing physical systems, deploy firewalls, cloud servers, and everything. And then we talk about the component, where we configure individual component, like set up the TLS certifications, WAF rules, and SIM systems. And then we ensure everything is working effectively, which is part of a management, which is called as a maintain and govern security, where we monitor logs, conduct audits, and ensure the compliance and everything. Now, once you're done with this, so enterprise security architecture, implement the information security strategy, which consists of layer of solutions, process, and procedures, and the way they are linked across the enterprise strategically, tactically, and operationally. So it play a very important role in building your strategy and execution. Then we move to the next part, where we discuss about different type of components. In the system component, the first component is called as a processor. So processor has a 3 function: multitasking, multiprocessing, multithreading. Multitasking and multithreading, remember that it has a one processor, whereas the multiprocessing have a multiple processor. Multitasking mean one processor execute multiple tasks. Multithreading mean one processor execute multiple threads of a different process. Multiprocessing mean multiple processors are hosting a one application. So that's there we have. Then if you move ahead, we also talk about the attack surface management. So attack surface management is a sum of all possible security risk exposure through which attack may compromise the systems. And you can think like that: if you increase the functionality, you're increasing attack surface; you're decreasing a functionality, you decrease the attack surface. So that is why we always believe enable only the unnecessary services and run only the necessary application which is required for the business. So attack surface is another important topic. So by reducing the functionality, you're increasing the security. And because the more entry points we have, the greater attack surface we have. Then we talk about the next section, which is called as a understand security capability of information system, in which we talk about the memory protections, TPM, cryptography modules, and HSM. So let's start with that part. So the first one is called as a memory protection. So we have a two type of memory. One is called stack and one is called heap. Stack is called as a fixed. Okay, so let's say example, there's an application who want to process in the memory. So the memory is fixed that okay, they cannot process more than 40 MB. It cannot go more than 40 MB. That is called stack. So here what attacker uses opportunity is they try to write more and more 40. As memory work on the LIFO, which is called last in first out, whatever you enter last, a malicious query that will be processed first in the system. So you can understand stack in this way. We have a stack of plates in cafeteria. You take the top plate, which is called LIFO, and plates are stacked and removed automatically in sequence. So limited space in the stack. On the other side, we have a heap. Heap is what, like it allocates the space according to the need of the application. So they read the application space and according to that, it allocate the memory. Now, if I say the application demand 100 MB, so it will allocate 100 MB. But here what happened, attacker manipulate the application from 100 to 200, but actual it is built on the 100 only. So when memory read that, it required 200, so it allocate 200, but actually it use 100 only. So with the left space, which is called 100, they use that to execute the exploits. So heap is like a disorganized pile of clothes in a wardrobe. So you can pick or place items anywhere, but it take time to find, organize them, and you must manually manage the wardrobe. Now what is important here is that what is the countermeasure for the stack and heap? So remember the answer is ASLR, address space layout randomization. I repeat, ASLR. So remember this, it is the most effective countermeasure for buffer overflow. I'll explain why. See, for example, buffer overflow attack required knowing two things. One is exact amount by which to overflow the memory. So one is that amount by which we can overflow, and the second is where exactly to send the overflow. So ASLR defeat the second item by randomizing the location. So it is difficult for the attacker to predict the locations, okay, and by which you can able to defeat the attack. So ASLR is a security technique used in a modern operating system to randomize the memory locations where the key programs components are loaded. And by making this location unpredictable, ASLR actually help to protect against certain type of exploits like buffer overflow and return oriented programming attacks. Okay, so always remember one thing: to prevent the buffer overflow attack in the memory, we basically use the ASLR. Okay, next important topic is very, very important for the exam is TPM, Trusted Platform Module. Yes, TPM. So TPM is a hardware-based security component that provide cryptographic capability and ensure the platform integrity. So even without BitLocker, TPM can be used for various security functionalities such as secure boot, key management, authentication, platform integrity verification. So let me explain you how TPM works. So during a boot process, TPM is actually a crypto processor chip which is integrated in the motherboard. Okay, it ensures that operating systems firmware components are in a trusted states. So what it does, it basically measure and record the hash of your critical boot component, which is called as a bootloader, in its platform configuration register, which is called PCR. And when it boot, if it any kind of modify, like if malicious change like rootkit is detected, the system may halt or alert the user. In Linux system, we use TPM to verify the integrity of the grub bootloader. So how it works is TPM generate the securely storage encryption key to ensure they never leave the TPM chip, and these keys are used to signing, encrypting or decrypting a sensitive data. So whenever you boot the system, they basically check the integrity state, then verify with the stored integrity state. If it match, then only it load the boot process. Now how today TPM use in the operating system? So what happened is initially when you're carrying your laptop and all that, and if someone snatch your laptop, he can take your laptop with you and he can bypass the password, and he can able to check the data and everything, because there's a lot of live CDs are available to bypass the Windows password or Linux password. So to overcome that, what happened is Windows introduced the feature of BitLocker. So BitLocker, what it does is BitLocker encrypt your entire operating system, and the key is stored in the TPM. TPM is enabled with the 4-digit pin. So when you start your laptop next time, it first TPM verify the configuration state, make sure it's loading in a secure integrity state. Remember that secure integrity state by comparing the hash with the stored hash. If it verify, then only it release a key to the operating system. Then BitLocker use the key to decrypt the operating system, and then it load the operating system. So tomorrow, if someone take your laptop, he still need those 4-digit pin to authenticate or boot the process. Even you remove the hard disk from the laptop and connect to another laptop hard disk and all that will not work. So that is why TPM with BitLocker offer the effective data security. Now what is important here is you need to remember in TPM what is the algorithm they use. So they use RSA. TPM use RSA algorithm, which 2048-bit key. And the memory they use is called non-volatile random access memory. And they have a dedicated chip which basically store the key. Now same concept, if I'm using for the enterprise, we call it as a HSM. So thin line difference in TPM and HSM is a external box which is used to connect with multiple servers, and it store the key. So if the context talking about from enterprise point of view, then the answer is HSM. If the question or context talking about from endpoint point of view, the answer is basically TPM, because HSM is a separate black box. It's a rack mounted appliance securely in your data center, which is built in the model with the higher end server hardware security. So when we're talking about integration of servers and all that, then we use HSM, and then we use the perspective of endpoint, then we use TPM. Next topic is called covert channel. So we have a two type of covert channel. You should know that. One is called storage and one is called timing. Storage channel is all about reusing the storage, which is like a heap based buffer overflow. Timing channel is an example of race condition where you're connecting to the multiple server on the same time. So that is the first part of this particular section. Now next topic is security model. Very, very important for the exam. You should know this. Security model is a framework or a theoretical construct that define how enforce the security policy within the system. You can say security model talk about how the subject interact with the object. Let's say example, I work for the product company. They want to understand how a subject will interact with the object. So we have a different type of security model which define their rules. Okay. So it provides a systematic way to describe and enforce the rule of confidentiality, integrity, availability to ensure the protection of sensitive information and resource. Now, why security model is important? Because they help in the design and implementation of secure systems, and it also providing a guideline for evaluating and improving a security mechanism. And moreover, it ensures the security policies are consistently applied across the system. So security model, what it does, it take the policies. So first step is understand the policies, talk about what is the statement. Then based on the policies, the security model adopt, because security model translate your security policy into actionable rules, which include subject, which call user, process, entities who request the access. Then we have an object like file, database, or other resources that need a protection. And then third part is operation, like action, like read, write, and execute that subject can perform. And more important, rules, the condition under which the access control has been granted. So first security model is called as a Bell-LaPadula model. Bell-LaPadula model. So if the context in the exam talking about multi-level model, confidentiality, first model focus on department defense, the answer is Bell-LaPadula model. And this model basically have three rules: no read up, no write down, and strong start property. I highly recommend to check my coffee shots because I don't have a time in this podcast to cover in detail. So no read up basically mean lower subject cannot read the higher subject data, and no write down basically mean higher subject should not able to read write anything on the lower data. Simple, na? Like in your case also, you cannot see your manager data, right? So that's called no read up. So by this we maintaining a confidentiality. And no write down basically mean that higher subject should not leak any information to the lower subject. Let's take example of WhatsApp, right? So accidentally you're sharing a data on a wrong group, which is readable to everyone. So there is a possibility that higher subject might leak some sensitive information in the low sensitive area. And third is called as strong star property. So Bell-LaPadula focus on confidentiality. Second is called as a BIBA model. BIBA focus on the integrity. Again, it is used in a Department of Defense only. It focus on integrity. So we talk about three rules: no read down, no write up. No read down mean higher subject will not read from the lower subject data. Same like, as a manager, you will not directly trust all the data coming from the operations, because based on that, you have to take a decisions. So that's why called no read down, because higher subject should not read the lower subject data because it impact the decisions. On the other side, no write down mean that no write up mean the lower subject should not able to alter the management data. And third is called as an invocation property. Invocation property mean that lower subject cannot request on behalf of higher subject data. Example, like I cannot request on behalf of my manager. So both models, Bell-LaPadula, BIBA, focus on Department Defense. Then we introduce Clark and Wilson. Clark-Wilson was the first commercial model, which is an extension of BIBA, focus on integrity. But they say that one person will not perform end-to-end transaction. So we have a concept of separation of a duty. So if the context talk about separation duty, answer is Clark and Wilson model. Then we introduce the concept of Brior-Nash model, which is called Chinese wall, which focus on preventing the conflict of interest. It means the developer will not able to interfere in production team, and production team will not interfere in the development team. Then once the product is ready, we move to the next level to obtain the certification. And one of the important topic in the exam is certification. So one of the certification, we talk about common criteria. So when the product is built, you basically obtain the common criteria certification, which basically help you to gain the trust in the market. And the benefit of common criteria is to add the buyer confidence, eliminate the duplicate evaluations, making the security evaluation more cost effective and all that. If you understand in this way, so if I'm building any, so I'm releasing one brand, okay, I'm launching one brand which is called wardrobe, or I'm launching some dresses and all that. So I will endorse by the Bollywood and Hollywood actors. Same like when you purchase any security products, it need to be endorsed by the independent certifications. So if you obtain some independent certification, it builds the trust. So common criteria is one of the certification body we have which evaluate the security capability of the product and certify them. So in common criteria, what happens is we have some component. The first is called protection profile. This is like a protection profile is nothing. It's like a minimum expectation we have from the vendor. So it is maintained by common criteria body. Like, hey, I'm a certification body and I'm expecting minimum AES encryption in your encryption software. So that is a protection profile, which is called as a baseline, which is the expectation, which is certification body has from the vendor. Then second is called as a target of evaluation. Target of evaluation is the product that is prepared by the vendor. He submit for the evaluation. And security target is a solution paper also prepared by the vendor, which explain how my product is meeting a protection profile. Okay. That's why, it's very important. And then based on that, they thoroughly test the product and then they assign the levels. So they have a level from EL1 to EL7. So you need to know this EL to EL17, not in detail, but you should know the sequence. So let's say example, we have a EL1, which is called functionally tested. So if you take an example of marriage function, like, basic function test, like proposal has been discussed about the marriage. Then EL2, which is called structurally tested, like family structure checked. EL3 is methodically tested and checked. It means detailed family and job verification has been done. Then EL4, methodically designed, test and review, which is called wedding planning begin. Then EL5 is called semi-formally designed and tested, which is called rehearsal and advanced check has been done. Then we have a EL6, semi-formally verified, design and tested, which is called rituals verified, near perfections, everything has been done. And EL7 is called formally verified, design and tested, which is like perfect wedding, guaranteed success and everything. So more levels you achieve, more assurance you obtain. So what happens is a lot of product companies, what they do, they have an internal CC evaluators. So before they're sending a product for a actual CC certification, the CC internal evaluators will evaluate everything. And according to that, they define the parameter. So this is the first part of the domain 3. In my next podcast, I'm going to cover about the cryptography. Thank you so much. Good day. Bye.